Hello everybody and welcome to this new video in my channel. Today I'm gonna show you how to calculate the flow rate in ParaView and how to plot this flow rate over time. So let's start. Here we have an open form case. These are the cases of the results. So let's open a new terminal, launch ParaView. And then apply. So this is our column. Here we have view bubbles. So in this column, we are injecting air bubbles from here, and it's dispersed in water. This is the outlet of air. So what we want to do is to calculate the flow rate in the inlet and later in the outlet. Then we want to plot this flow rate over time. So as you know, the flow rate is equal to the section multiplied by the velocity magnitude. So what we need to do is to start by calculating the magnitude of velocity. I'm gonna name it mag q. And here mag of vector u bubbles. Apply. So now in spreadsheet view, we will get another variable which is mag u. So yes, so it calculates the magnitude of the velocity of bubbles. Now, as we want to integrate this velocity, this magnitude on the inlet in order to get the flow rate, we will go and select filter, extract block, inlet, apply. Then we have this block, the inlet, and we will go and integrate our variables on this section. So here we have different variables. Here we have our magnitude integrated on this section. So this is our flow rate. We can uncheck the other variables that we don't need. Just go and toggle other variables one by one. So this is the flow rate. This is the flow rate of in the inlet. We can keep the U bubbles, so you can see that our flow rate is equal to the second component of integration of U bubbles, since we have the flow in the y direction. So it's all the flow is on the y direction. We don't have flow rate in the x or z directions. This is why we have this flow rate. The total flow rate is equal to the second component in the y direction. So now we have this variable. If you want to verify this variable by calculation, by the correlation S multiplied by U, we can get the area of this inlet, which is 0.015. Then go and see the velocity of the injection of bubbles. It's 0.1 in the y direction. So if you just multiply the S by U, you're gonna get this value of the flow rate. So this is the flow rate for this is the flow rate in the inlet. Let's now plot this variable over time. Just filter, plot data over time, apply. here I'll just check all the other variables in order to get only MagU. So here we can't find the variable U bubbles and MagU because in the problem is in the initial step, which is 0, does not contain this this variable. So we're gonna just close this, go here, eliminate the 0, skip, delete this folder, open in terminal, our phone, and then we're gonna do all the previous operation, magnitude of U bubbles, MagU, then filter, extract block, inlet, apply. So it's good for you also to revise all the steps here with me. Recent integrate variables, apply. Here we have all our variables. So here is the MagU. So now we're gonna try the plot over time to see if it does plot our flow rate. So now we have all our variables. We need just to incheck, then go to MagU. So it's equal to 0.0015 in all the time. So now let's go and calculate the flow rate in the outlet. We can just go here and modify, extract block here, modify to outlet, and then apply. So here we have the variation of the flow rate over time. And it's very obvious since we have, as you can see here, U bubbles. You can see that we don't have uniform outlet of the air bubbles here, so we have this type of flow rate. So this is all for this video. Thank you for watching and see you in next video.